Hello friends, welcome everyone in my channel selfstudy.com. This channel is based on electrical engineering study material for diploma and engineering students. Here you can get home tutorial lessons in different subjects of electrical engineering. If this channel is helpful to you, then subscribe and click bell icon for further notification of uploads. Today's topic is DC circuit. I will divide this total topic in two lessons. This is the first lesson. So let's start today's video. Electricity. What is electricity? Electricity is a term used for all phenomenon caused by electrical charge, whether it may be static or dynamic. Then, what is electrical circuit? Electrical circuit is nothing but a collection of all type of electrical elements, resistance, inductive coils, capacitance, and power supply, in such a manner that may cause a flow of electrical charge. Here are some definitions of basic parameters in DC electrical circuit. The first parameter is electrical current. The flow of electrons in any closed circuit is called current. The SI unit of current is ampere, which is denoted by capital A. Means what we can say, if in any closed circuit the flow of electrons happens, then we can say an electrical current is flowing through this circuit. Now the second point. The second point is electrical potential. The capacity of a charged body, either positively or negatively charged, to do any work is called electrical potential. Now the third point, the main point, electrical potential difference. What is that? The difference between electrical potentials of two charged body is called potential difference of these two body. This is actually called the voltage between these two body. This is denoted by capital V, and the SI unit of this potential difference or voltage is volt. And the fourth parameter is the resistance. It is nothing but a property of a material. By virtue, this material can oppose the flow of electron through itself. This property called resistance. SI unit of this property is ohm, denoted by capital R. Here are two important points for you guys. Inductance and capacitance property does not have any significant role in DC circuit. The reason will be discussed in later. And the power supply unit of any DC circuit is nothing but a source of potential difference, or means voltage actually. Now the Ohm's law. George Siemens Ohm, a scientist who defines actually this law. That's why it's called Ohm's law. The electric current flowing through a conductor is directly proportional to the potential difference between two ends of this conductor. Here you can see the picture. There is a R or resistance. Across this resistance we applied a voltage V, which is called V. For this voltage, the current will flow through the resistance. So if we can keep other physical conditions unaltered, we can say from this law the electrical current flowing through a conductor, means this conductor, is directly proportional to the potential difference between two ends of this conductor. Means we can increase the potential difference between these 2 points or two ends of the conductor. We can change the value of current. So we can say current, which is denoted by I, and voltage, which is denoted by V. I by V equal to constant. And what is the constant is? The constant is resistance. Means we have one more element above which the current can also change, that is the resistance of the material. If we can change this, then also current will change. If we change voltage, then also current will change. So from these three things we can say I by V equal to R or V equal to IR. This is what actually Ohm's law states. Laws of resistance. Now, what is resistance? Resistance, we have discussed here, it is nothing but a property of a material. By virtue, this material can oppose the flow of electron through itself. So, what is the law of resistance? Resistance of a conductor material is directly proportional to the length of the conductor and inversely proportional to the cross section of the conductor at constant temperature. If we can fix the temperature of any conductor material, we can say the length of the conductor and the cross section of the conductor can define the total resistance of this conductor. Directly proportional to the length of the conductor and inversely proportional to the cross section of the conductor. Means if we can increase the length of the conductor, we can increase the resistance of this conductor, and if we can decrease the cross section of the conductor, then also we can increase the resistance of the conductor. So R equal to constant into length by cross sectional. Then what is the constant? The constant is called the specific resistance. It is a term. Let's discuss the specific resistance of a material. The specific resistance of any material may be stated that the resistance offered by unit length of this material having unit cross-sectional area is the specific resistance. SI unit of specific resistance is ohm meter, and this is also known as the resistivity of any material. Here you can see the picture. We have a 1 meter length of conductor material having 1 square meter cross sectional area. The total resistance will be offered by this total amount of material will be its specific resistance of this material at a certain constant temperature. Now let's discuss the factors at which resistance of any material depends. The first factor is the length of the material. From laws of resistance, we know the length of the material is directly proportional to the resistance. Means if the length of the material increases, then resistance of the material is also increases. The second factor is the cross-sectional area of the material, which is inversely proportional to the resistance. Means if cross-sectional area of the material decreases, the resistance of the material will increases. Third, the resistivity or the specific resistance of the material, which is directly proportional to the resistance. From above figure and the definition of specific resistance, we can say that if resistivity of any conductor material increases, then the total resistance of the conductor material will also be increases. And the fourth point is the working temperature of the material, which is directly proportional for conductor material. Means if any material working temperature got increases, then the total resistance for the conductor material will always be increases. And the fifth and the last factor is the nature of current flowing through the material. If the AC current will flow through the material, then an amount of resistance will be different from if the DC current will flow through the same material. So here we can say the current, the nature of current will always determine that how much resistance of this conductor material will be countered. Now see the effect of temperature on resistance of various materials. So here are three types of conductor material. First is pure conductor material, which is silver, copper, gold, etc. These are the pure conductor. Here, with increase of temperature, resistance of this material will also increase. And the second type of conductor material is alloy conductor material. Bronze, babbitt, etc. These are the alloy conductor. Here, with increase of temperature, resistance will increase, but with a irregular manner. Isolator and semiconductor material is the third one. For this material, resistance will decrease with increase of temperature. For this type of nature, semiconductor materials are used for making an electronic circuit. Now, let's see the temperature coefficient of resistance. What is the temperature coefficient of resistance? The temperature coefficient of the resistance of any material is the change of resistance in the material per ohm per degree of temperature. This is denoted by alpha. Means if we can increase 1 degree centigrade of temperature of any material, then how much resistance will be increased, that will be the temperature coefficient of the resistance. If 1 degree temperature rises can occur 1 ohm of resistance increase, then it will call the temperature coefficient of resistance is 1. Now let's figure out the formula how we can find out the temperature coefficient of the resistance. Let's say R1. R1 is the resistance of material at T1 degree centigrade. Suppose. And R2 is the resistance at T2 degree centigrade. So here see the picture. If a conductor is having R1 resistance at T1 degree centigrade, after rising the temperature, its resistance becomes R2 at T2 degree centigrade. This rise in resistance with rise of temperature depends upon following things. First thing is the change of resistance is directly proportional to the initial resistance. Here R1 is the initial resistance. And the second point is change of resistance will be directly proportional to the change of temperature, which is T2 minus T1. Initial temperature was T1 and after rise of temperature it becomes T2. So the change of temperature is directly proportional to the change of resistance. And the third point is the properties of the conductor material. So the properties of the conductor material means the specific resistance. It also important. So by combining of these three effects, we can find this equation number 1, which says that R2 minus R1, which is a change of resistance, is equal to the alpha and the change of temperature and the R1. The product of temperature coefficient at T1 degree centigrade and the temperature changes and the initial resistance is equal to the change of resistance. Now from equation 1 we can get the equation number 2, which is R2 equal to R1 bracket 1 plus alpha, which is the temperature coefficient at T1 degree centigrade, into the change of temperature. That is the equation number 2. If alpha 0 is the temperature coefficient at 0 degree centigrade, alpha 0 is the temperature coefficient at 0 degree centigrade, then from the equation number 2, the resistance of the material at T degree centigrade will be this: RT equal to R0 into 1 plus alpha 0 into T. That is the third number of equation. Now, from third number of equation, we can derive R0 equal to RT into 1 plus alpha T into minus T. Alpha T is the temperature coefficient of T degree centigrade. Alpha T is the temperature coefficient of T degree centigrade. Now from 3 and 4 number of equation, R0 by 1 minus alpha T into T, which is actually the RT value, equal to, we can write the 3 number of equation, the number 3 equation, and from this we can write R0 and R0 are got cutted, and from that we can tell 1 by 1 plus alpha 0 into T equal to 1 minus alpha T into T, and from that alpha T equal to 1 minus 1 by 1 plus alpha 0 into T, and from that we can say alpha T equal to alpha 0 by 1 plus alpha 0 into T. Means alpha T is the temperature coefficient of the resistance of any material at T degree centigrade, and alpha 0 is the temperature coefficient of the resistance of this same material at 0 degree centigrade. If we can know that the value of alpha 0 means the temperature coefficient resistance of the material at 0 degree centigrade, and if we also know that the temperature after rising of temperature, how much temperature of this material is having now, then we can find the temperature coefficient of the resistance at present temperature of this material. That is called the temperature coefficient resistance formula. Now let's discuss the resistance in series and parallel using Ohm's law. First is resistance in series. If any circuit consists n number of resistors and the current through each resistor is equal, then we can say these all resistors are connected in series. So then the total resistance would be the summation of each resistors. Here you can see the formula R equivalent equal to R1 plus R2 plus tends to Rn. The summation of all resistors in series will be the R equivalent resistance, means total resistance. And now see the resistors in parallel. When the voltage drop across each resistors will be equal, then we can say the all resistors in this circuit is in parallel. So here you can see the formula 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus tends to 1 by Rn. So please try to remember these two formula. One is for resistor in series and another is for resistors in parallel. Now let's see the power formulas and how it is calculated in electrical circuit. Power is a measure of how much work can be done in a given amount of time. Mechanical power is commonly measured in America in horsepower. Electrical power is almost always measured in watts, and it can be calculated by formula P equal to I. Here P is the electrical power and I is the current and E is the voltage. Electrical power is a product of both voltage and current, and not either one separately. Horsepower and watts are merely two different units for describing the same kind of physical measurement. So here we can find relating terms, that is 1 horsepower equaling 745.7 watt. Relation between two different types of uh, power, mechanical power and electrical power. 1 horsepower equal to 745.7 watt. You have to remind this. Now try to calculate a electrical power of a electrical circuit. Now let's assume a 3 ohm of lamp is connected in a circuit where the applied voltage is 18 volt. 18 volt. This is 18 volt. And this is 3 ohm lamp. From Ohm's law, we can find out the current will be flowing through this lamp. I equal to E by R, then 18 volt by 3 ohm equal to 6 ampere. So, the current flowing through this lamp will be 6 ampere. Now, from the formula P equal to I into E, we can find out how much power will be consumed by this lamp by multiplying current and voltage. Here is the current is 6 ampere and voltage is 18 volt. So the product of these two is 108 watt. So we can say that these 3 ohms of lamp load can consume 108 wattage of power if this lamp is connected with a 18 volt of battery supply. Let's see voltage divider circuit. Here we will analyze a simple series circuit determining the voltage drop across individual resistors. Here in one number of figure you can see a 44 volt of battery is connected in a circuit which consists three resistance R1 5 kilo ohm, R2 10 kilo ohm and R3 7.5 kilo ohm. If this all data we can put in a chart. Here this is a chart. The total voltage is 45 volt and the total resistance will be 22.5 kilo ohm because these three resistance are connected in a series, and from resistance in series formula we know that the summation of all resistance will be the total resistance for series resistance circuit. Then total resistance will be 22.5 kilo ohm. And then next, if we have the voltage quantity and the resistance quantity, from Ohm's law we can find the total current, that is 2 milliampere for this circuit. Total 2 milliampere current will be flowing through this circuit and through all resistors. Then in figure number 4 we can see that the voltage drop across each resistor is in that pattern. For 5 kilo ohm resistors, if 2 milliampere current flowing through this, then 10 voltage will be dropped across this resistor. For 10 kilo ohm resistors, for 2 milliampere current, 20 voltage drop will be occurred in this resistance, and for R3 it will be 15 volt. So total 45 volt will be divided in 3 resistance. For R1 10 volt, for R2 20 volt, and for R3 15 volt. Now if we were change this total voltage to 180 volt, we would find the proportionality of voltage drop across resistors remain constant. For 180 volt and for total 22 kilo ohm, total 8 milliampere current will flow through the circuit, and for that voltage drop across R1 will be 40 volt, for R2 will be 80 volt, and for R3 will be 60 volt. The voltage across R1 for example was 10 volt when the battery supply was 45 volt. When the battery voltage was increased to 180 volt, 4 times as much, the voltage drop across R1 also increased by a factor of 4 from 10 volt to 40 volt. The ratio between R1's voltage drop and the total voltage, however, did not change. In first circuit, we found that voltage drop across R1 is 10 volt and total voltage was 45 volt. Then the ratio would be 0.222, and in this circuit where the voltage increased to 4 times means 180 volt, now the voltage drop across R1 is 40 volt. So here is also the fraction is 0.222. So we can see that the ratio between R1's voltage drop and total voltage did not change, although the applied voltage increased 4 times. So for this reason, actually likewise others two resistance also maintaining this proportionality or fraction. So for this reason, a series circuit is often called a voltage divider for its ability to proportion or divide the voltage into fractional portion of constant ratio. Now let's see the current divider circuit. Let's analyze a simple parallel circuit determining the branch current through individual resistors. Here in one numbers of figure, you can see a 6 volt of battery supply is connected in a circuit which circuits consist 3 resistance are in parallel: R1 1 kilo ohm, R2 3 kilo ohm, and R3 2 kilo ohm. If we put all this data in this chart, figure number 2, for 6 voltage of total current for R1 will be 6 milliampere for 1 kilo ohm resistance, and for R2 3 kilo ohm resistance the current will be 2 milliampere, and for R3 of 2 kilo ohm resistance the current will be 3 milliampere. The summation of total current is 11 milliampere, which is shown in chart number 3. Then the current through R1 is twice as much the current through R3, which has the twice of the resistance of R1. Means R1 has a resistance 3 kilo ohm, 1 kilo ohm, but R2 has a resistance 3 kilo ohm, means resistance is 3 times higher. That's why the current is also 3 times lower for the R2 circuit, R2 resistance. If we had to change the supply voltage here also up to a value which is 24 volt, we find that the supplies, this proportional ratio do not change. Here we increase the voltage from 6 volt to 24 volt, and all other resistance are remain same, 1 kilo ohm, 3 kilo ohm and 2 kilo ohm. Then for 24 volt and R1 resistance of 1 kilo ohm, 24 milliampere current will be flow through the R1 resistance, 8 milliampere current for 3 kilo ohm resistance, and 12 milliampere current through 2 kilo ohm resistance. Then here the total current will be 44 milliampere. But one thing we have to observe, the current through R1 is still exactly twice that of R3. R3 12 milliampere and R1 24 milliampere. Despite the fact that the source voltage has changed. So here also the ratio between any branch current and the total current remains unchanged. In previous circuit, 6 milliampere was the current flowing through the R1 resistance and total current was 11 milliampere, and in this circuit R1 current is for 24 milliampere and total current is 44 milliampere. So the ratio becomes same or remains unchanged for three resistance. This all For this reason, a parallel circuit is often called current divider for its ability to proportion or divide the total current into fractional part. You have to remind these two formula. One is for voltage divider formula and another is for current divider formula. If you can, if you want to find actually the voltage drop across any resistance of a total n numbers of say series resistance circuit, then you can find the voltage drop using this formula. Here E total is a total applied voltage, R total is a total resistance, Rn is the nth number of resistance, and En will be the voltage drop across nth number of resistance. And for current dividing formula, I total is the total current, R total is the total amount of resistance, and Rn is the nth number of resistors value, and In is the current flowing through this resistor. Means nth number of resistance, how much current will be flowing through this resistance. That formula can be used for finding out that same. Now here are one numerical for finding the equivalent resistance. Let's see this circuit. For we have to find actually the total resistance across A and B point. Here is the question: what is the equivalent resistance between point A and point B? Now for finding out that, we have to progress through some step. First step, see 10 number of 10 ohm resistance and 15 ohm resistance is in series. These two resistance is in series. So the total resistance will be 25 ohm. Then step 2, 30 ohm and 25 ohm resistance would be parallel. 30 ohm and 25 ohm would be parallel. So their total resistance will be 1 by R equivalent equal to 1 by 30 plus 1 by 25 equal to 0.073, and R equivalent equal to 13.6. So the first step is for calculating the total resistance of 10 and 15 ohm series resistance, which is 25 ohm, and this 25 ohm and 30 ohm are in parallel, so their total resistance is 13.6 ohm. Now see this figure. 30 ohm and 25 ohm are in parallel, so their resistance is 13.6. Now this 13.6 and 20 ohm are in series, so their equivalent resistance is 33.6, which are now in parallel with 15 ohm resistance. Now the two equivalent resistance of parallel two resistance 15 ohm and 13.6, 33.6 is 10.4 ohm. So we have to take 4 steps for solving this question. First step, finding out two resistance which are in series, then make sum of these two resistance and find a one single resistance. Then step 2, this total resistance of 10 plus 15 ohm are in parallel with 30 ohm. Then their total resistance is 13.6 ohm. Now step 3, this 13.6 ohm and 20 ohm are in series, so their total resistance is 33.6. And step 4, 33.6 and 15 ohm are in parallel, so their total resistance is 10.4 ohm. So total resistance means equivalent resistance between point A and point B is 10.4 ohm. Thank you. If you find this channel as well as this video is needful to you, then please subscribe and click bell icon for further notification. Next topic that will be discussed for DC circuit, lesson 2, DC network theorems, DC circuit network theorems, KCL and KVL laws, network analysis technique.